the Penn State Senior Design Project, we worked with Boeing to develop a system for sensing the air pressure below a helicopter rotor. With 12 weeks and $1,000, we quickly went into rapid prototyping of a system that would be able to meet the objectives. To validate some of our design concepts, we used an initial prototype made out of readily available materials with low-cost construction techniques. In 1 week, we were able to prove which ideas worked and which didn't. Following the initial prototype, we moved into the final design phase with CAD modeling and advanced machining techniques. At the Penn State Learning Factory, we had access to advanced machinery and all the tools necessary to quickly move through our fabrication and design processes. Through the design process, we received a lot of assistance through our sponsors at the Boeing Company, faculty at Penn State, and the staff here at the Learning Factory.
For the azimuthal system, we went with a combination of a large diameter lazy Susan bearing and a timing belt. The timing belt is attached to the outer race of the bearing, and the outer race is fixed to the base of the system. And the timing belt pulley is driven by a very high torque stepper motor, and through this special bracket, the pulley is attached to the inner race of the bearing, which is free to move, and that allows the system to rotate from 0 to 330 degrees.
This is the radial portion of our project. It was created from 2 pieces of rigid conduit, 2 electrical boxes. It's driven by a screw in the middle, and it gives us a range of motion from around 9 inches from center to about 36.
For the vertical motion component of the design, we chose a scissor lift. This allows us to keep all of the mechanical components well below the tip of the pitot probe so that they aren't interfering with our flow measurements, while still allowing us to have a very stable position and a full 18-inch range of motion.
After developing a system for moving the probe in 3 dimensions, we then created drive mechanisms for these 3 degrees of freedoms. All these drive mechanisms use stepper motors. These stepper motors, through the use of hardware and software, can be moved precise increments, giving us a high level of accuracy for the positioning of the probe. To measure the downwash of a helicopter rotor at a specific point, we're using a pitot-static probe with a differential pressure transducer. This pressure transducer outputs an analog voltage and is then sent to our signal conditioning circuit.
We need a signal conditioning circuit to amplify the incoming signal and to attenuate certain frequencies.
Alright, so here's our graphical user interface. When the user opens up the program, they have the option to hit enter positions. Once they hit enter positions, they enter the azimuthal positions, radial positions, and the heights that they want. Once all the heights that they want have been entered, they will click collect and process data. Once that button has been hit, all the data will be sent to the Arduino microcontroller wirelessly. Once the microcontroller collects all the data, it will send signals out to the 3 different motors, which will move to their respective positions, and a pressure probe reading will be read. Once the pressure probe reading is read, the data is sent back to the Arduino microcontroller and sent back wirelessly to the computer for graphical interpretation on our GUI right here, and data interpretation right here.